Hello, everybody, and welcome to Autodesk Fusion Generative for Manufacturing. My name is Mike Fiedler. With me is Apollo Vanderberg. We are both enterprise simulation specialists here at Autodesk, and we're going to walk you through today's topic. We also have our colleague Anton Fedosayev with us, who will be assisting with some of the questions and additional information. So let's go ahead and get started on today's topic. The agenda, the welcome, which we just covered, we're going to talk to you about generative design and manufacturing. What is it exactly? We will also cover a brief demo of the software. And at that point, we have a little bit of a recorded presentation so that you can see what the basic workflow is, how you might get through the software in a start to finish sort of fashion. Of course, it'll be kind of condensed so that we can get through that efficiently, quickly. But then as we get into the next steps in the Q&A portion, we will also have the program open and ready with a model so that if we can take a deeper dive into that for you, if there is anything that you see during the demo and you say, hey, I'd really like to see a little bit more about that, I need to understand that a little bit better, that is your opportunity for us to show you more about the software. So all in all, we have the demo scheduled for an hour. We certainly allow for a good amount of time on the question and answer session. It's really what Apollo and I look forward to on this presentation. What is it that you're interested in that you would like to try and accomplish with the software? So it's important to us to answer as many of those questions that you have as possible so that you can be successful with the software. So let's go ahead and move in to the content. So I want to start with why do we care, right? Before we learn anything, whatever that software is, we work for a company which leverages other softwares beyond our own products. And when our teams come to us and say, hey, there is access to this new product, the first question that always pops into my mind is, do I need this software? Why do I care? What is it going to do for me? And what I wanted to do with these slides, this slide in particular, is hopefully answer that question to some degree. And really what I want to start with is the software is in use by customers, colleagues, other companies now currently. And when we started this this webinar series, I think it was pretty close to the introduction of generative design to the user community, right? So a lot of people at that point were really like, what is this software? Is it beta software? Is it something you're just wanting us to explore to see if there's value, et cetera? And now here we are, a good ways down the road, more than a year that we've been doing this presentation. So I just want to make sure that you are aware that people are doing good things with the software. And we'll look at two examples here. On the left-hand side, there's General Motors, and you may have seen the seatbelt bracket example where they took an 8-part assembly and utilized generative design to make it out of a single body. So of course, part consolidation would be one reason that you might leverage the software, and one of the benefits of that is the ability to optimize it for mass. So you take a multi-part assembly, make it a single body, and save mass in the process of doing so. And then of course also the second benefit of that is reducing your supply chain costs associated with each one of those components of the assembly and its unique supplier. So also tracking less components that would go into that assembly. The second thing that you see on the right-hand side there is a wheelchair from Disrupt Disability. And they've been able to make wheelchairs more versatile, customizable, and to a degree, you might even say a fashion item. And also, because you are inputting into the program certain parameters, you can also tailor it to a unique person's measurements. and then also interchangeable parts based on need. So not necessarily a standard configuration or a design, that it would be utilized across the board. It can be tailored a little bit more. So again, it is in use today, and I think a good site for us to show maybe a little bit further on in this presentation would be the customer success story. So there is a web page that is all geared around different customers that are currently utilizing generative design and some of the successes that they've had with it. So something that we'll try and show a little bit later on in this presentation. So what is it overall? We describe it as a design exploration technology. And what it does is it simultaneously generates multiple CAD-ready solutions that are based on real-world manufacturing constraints and product performance requirements. So I'm going to dissect that a little bit. First of all, multiple CAD-ready solutions. And if you look to the right-hand side, the light blue seats that you see there, that's kind of the idea, or one of the ideas behind generative design, is to be able to produce multiple outcomes, certainly more outcomes than what you or I alone tackling a particular design problem could potentially think of or have the time to dedicate to try to come up with. And then we say based on real-world manufacturing constraints, because that is part of your input to the program. Well, obviously, the program needs some information from you. What sort of loads do I need to withstand? What are my constraints? Where am I held? Am I allowed to translate? Am I allowed to rotate in particular directions? And then, what sort of materials are we going to utilize? What can we use from a manufacturing standpoint as far as the production capabilities? Is it going to be 3D printed? Is it going to be something that is CNC machined, etc.? So these are inputs that you give the program. And then also there are product performance requirements. You can place restrictions on what you want the safety factor to be, for instance. So it takes all this information in and then hopefully produces a lot of viable outcomes for you. And then you can decide on what is the best outcome. And we're going to dive into that further. So we can take a look at how all that information goes into the program. All right, so what we want to do here is kind of a high level, talk about how the design, Autodesk Generative Design helps your product development process. So just for a minute, envision that you are tasked with coming up with a new product or redesigning an existing product, right? You might come up with a few different concepts. Just dedicating some time. Certainly, we've all done this. It could either be you, or maybe there's a small team, you and a couple of your colleagues that go and sit in an office, or these days maybe jump onto some sort of web sharing platform and come up with a few different ideas, right? And then you try to take that best idea and validate it. Is it something that is able to be manufactured? Do we think that the cost will be acceptable? And you're basically evaluating that particular concept, and sometimes you have to go back to the drawing board and say, well, no, it wasn't. Let's take a look at this other concept that we had and determine, is that manufacturable? Is it going to be cost effective? And so on. So ultimately, you get one of these ideas, hopefully through validation, and then you can produce it. So what you have here is a rather long iteration phase, and you also have a potentially long design to production phase until you come up with a particular outcome, like this motorcycle swing arm that you see on the right-hand side here. When we contrast this with how the generative design is going to help you, we're going to take a look at something like this motorcycle triple clamp. So you might have an existing design, or at least some sort of design that you're using as a guide for ultimately what you want to produce. And maybe, you know, you have something that in a conventional design might look something like the image that you see there at the bottom. But if we were to run that through generative design, what we're saying is it's going to improve your productivity. Why? Because it produces multiple validated manufacturable options. So that is one of the greatest outcomes of generative design, is that it produces many validated manufacturable options. And again, that ties back to what I had mentioned earlier, where you are giving the program information about what loads it needs to withstand, what materials is it able to choose from, you know, what manufacturing methods can you utilize. So taking all that information in, then the output of the program are all these different manufacturable options. And then you can select those different outcomes and investigate them in greater detail. So for instance, if we look at one of these, we see, okay, this is a die cast outcome, the material that it utilized. And then we start to consider different aspects of it. So we can analyze the cost and say, hey, great, you know, this is a relatively low cost item. Our customers will like that. But we see the mass is relatively high. So maybe that has not done a lot for us, or maybe one of our selling points was that it had a low mass. So we look at something different, a different outcome, and we can say, okay, this is a additive one. So, well, because of the fact that it's additive and the material, the cost is going to be relatively high. It's fabulous that the mass is low, but are we going to be able to sell this product at such a higher cost, right? So we can start to explore the different outcomes that we have until we settle on something, and maybe ultimately we settle on something that is a 2.5 axis CNC part made out of aluminum, which has low cost, which is great, right? We can market that more easily to a larger market, and the mass is less than maybe what the original body was, right? We can see that we machine out some pockets here. So that way we can also sell and say, hey, you know, here's why you're going to buy our part. It's cost competitive to a traditional design, but it's also a lighter mass part. So that would be the benefit of it, right? And now, as our next topic of discussion, we're going to contrast topology optimization versus generative design. So you may have heard about or seen other technologies that are topology optimization. And in fact, topology optimization exists in Fusion and also within the Inventor product. And we're going to utilize a transportation analogy to discuss and contrast topology versus generative design. So let's imagine that you have a product that you need to ship, and you take it from point A to point B, and going from point A to point B, you go all the way around South America and up to the West Coast of North America with your product. What topology optimization does is it basically lightweights a part. So it takes a standard existing body with known constraints, known loads, a known material, and it basically makes it lighter. It figures out where to remove material, or in the case of our shipping analogy, it finds a faster route, right? So that's what topology optimization does. It's doing a single objective, and that would be, let's make this part lighter. But it doesn't explore different materials. It doesn't explore different constraints or manufacturing methods or anything like that. It's simply, how do we make this lighter? Or again, in terms of transportation, how do we make it faster? Whereas with generative design, we do that still, but then we're also going to add in additional things. So that would be the equivalent of adding in or exploring a truck route, a train route, a plane route, right? And that would be your different manufacturing methods, the different materials. You can add in additional cases to explore different loads, etc. And then you get multiple outcomes, right? So in the case of this transportation analogy, you have to weigh different things like how much cargo can it carry? What's the different speeds that it goes out? What are the costs and security? in terms of the outcomes of your generative design, it would be what are my masses? What are the deflections? What are the different materials and manufacturing methods which play into how much does this part cost for me to make, really, right? So certainly you want to stay within a certain range of cost. You want to stay with a certain range of safety factor or how much stress the part experiences. And so on. So we'll take a look at those, what those specifically or what that specifically means to you in terms of the generative design program and what it's able to output here shortly. This next slide, when to utilize generative design. This is something that Apollo and I put together. When we were thinking about it, generative design is I hate to say it, but it has a bit of a wow factor, right? It's a newer technology, and I think that draws a lot of people to it just by virtue of it's something that is new, right? We've been drawing. If you think about AutoCAD and how long AutoCAD's been around, we've been drawing on the computer for quite a number of years now, and then things like mechanical desktop came onto the scene ultimately and into Inventor, and 3D modeling was really awesome. And it's now something that we use probably every day. And then generative design comes on the scene. Everybody says, hey, I want to take a look at that. When might you actually want to use it? Where can it help you? And we see basically three different instances, at least three different instances when you might want to leverage it. And certainly new product design would be a fantastic time to use it. So if it's a completely new product, and you don't already have some set design in your mind, generative design can be useful as a design guide. So you input, again, your constraints and your loads and basically your what do you want to say? The materials and your manufacturing methods, and then allow generative design to come up with where is the material needed, what types of materials would be good to utilize for this design. And again, hopefully what we hope, that was an interesting statement, interesting way to put it. What we expect to see is that you can explore more design alternatives beyond maybe what you would have come up with just on your own or just with one of your colleagues, right? And then, you can use that generative design result and manipulate it as you see fit for production. You don't absolutely have to take the exact outcome of generative design. You can use that as a guide for your own ideation from there. So maybe you see one of the outcomes and you say, hey, I like that. It's an additive outcome, and I don't plan to manufacture this with the additive manufacturing. So maybe whenever you take that design, ultimately you go back to something like the Inventor program, and you use that as your foundation for your design. Next would be part consolidation. So do you have costly or hard to manufacture assemblies? You can put those into generative design and perhaps see if you can consolidate that into a single body based on how generative design sees the constraints and sees the loads and what the load path needs to be. And thereby you can reduce the amount of raw materials getting utilized. You can reduce the number of components that go into that assembly and hopefully come up with a better outcome than the as-is assembly. And then lastly, part enhancement. So, I spent a lot of time talking about new product design creation, and certainly, I think that's a good fit. But there's no need that or no reason that you couldn't apply this to already designed parts. So you could take your current part catalog, a part at a time, or maybe your top 3 parts, and put them into generative design with the constraints, with the loads. Maybe you looking at different materials and saying, are there ways that we can optimize or enhance this design? Can we lightweight it? Can we increase its structural integrity? Can we make it a more durable part? So you can certainly leverage it with designs that you have today within your portfolio. All right, let's talk about some of the outcomes. kind of maybe an overarching outcome would be to strike the right balance between performance and cost to produce, right? So we know that everybody wants to have, a good performing part, but at the same time, you have to balance that with how much it costs, right? You don't want to make a part that is so expensive that nobody's going to buy that, but then you also don't maybe want to necessarily be at the lowest end of the spectrum too, right? Where people don't think that your product offers any value. So you got to kind of find that balance. And at the same time, taking a look at that second bullet point there, we know that engineers are limited in how much time and energy you can spend on the design problem. So you might be only given a half day or a day or a week in order to take a look at this new design or to optimize this design. So really, we hope that generative design is going to help speed up that process where you can dedicate fewer people and a lot less time to being able to come up with a lot more ideas. All right, let's explore that just a little bit more. And we're going to do that with something called the price performance curve. And again, trying to strike the balance between cost to produce and the performance. We're first going to look at that again with something of a transportation analogy. So, if we take a look at something everybody understands, right? We can look at this in terms of cars. What is the performance of the vehicle? And what is its cost to produce? So at one end of the spectrum, we might have a vehicle which is low cost, but at the same time, the performance aspects of it might be not exactly where we want to be. And at the other end of the spectrum, we can have vehicles which have awesome performance, but at the same time have an extraordinarily high cost in order to produce it, and therefore you take people out of the market for it, right? I don't know if everybody saw, there was just an article this week that I thought was kind of interesting. A vehicle which is, just timed to well over 300 miles an hour in Las Vegas. The performance is just awesome, right? You read that article and you go, man, that's incredible. Able to go over 300 miles an hour. And then you get to the bottom of the article where they tell you how much it costs, and I go, well, that takes me out of it, right? I need to be somewhere down here, more towards the middle of the spectrum, right? So anyway, generative design is going to give you all these different outcomes. And then really with all those different outcomes, you can decide where you want to be within this price performance curve. Obviously, we know that there are vehicles at this end and there is a market for them, and certain people will take advantage of that. And if that's where you want your product to be, great. We're not limiting you to where you are on the price performance curve. Generative design is going to give you all these outcomes along with cost, and then you can decide, where you want to slot your product. All right, so let's take a look at something maybe more towards the engineering end of the spectrum, something that we can all be familiar with. So there's a bracket here, and this is a GE Aerospace bracket, and the design is held in these 4 holes, and then in these 2 lugs, there are a series of different loads, horizontal, vertical, and moments. And the company was interested in redesigning this part. Can we keep it at least as strong, but maybe make it more lightweight, right? Certainly a concern for the aerospace industry. And maybe we're interested in exploring different manufacturing methods. Maybe we're open to making it out of different materials. So a few years ago on GrabCAD, they put forth this challenge. They exposed this part to the user community and said, look, here's where our constraints are, here's where the loads are, what ideas are out there for how we can redesign this. And the user community delivered. So these are some images of some of the different designs that the user community came up with. And of course, we could lay those out on the price performance curve, right? Some of them are high performing, but also would cost a lot to produce, and other ones are at the other end of the spectrum. But one of the things that I would like to point out about this is it took hundreds of users, right? And they left it open for several weeks. maybe a month. So the user community did deliver, but how often can you do that, right? Can you dedicate, you know, do you have hundreds of employees that you can, you know, give this task to and say, hey, I want all of you to come up with some ideas for this bracket, how we are going to redesign it, what materials are we going to use, what different manufacturing methods are we going to use. I would say that's, you know, rather unusual, and I don't know that you necessarily want to take every single one of your parts and make it a grab CAD challenge, right? I think that's just impractical. So what we can do is give this sort of task to generative design. This would be a great model to say, look, I have constraints here. These are the 4 locations where I need this part to be fixed. It has to attach to something else. And this region up here, you can also make that a region that you want to keep because these are where your loads are going to be, and you define what those loads are. And then you just leave it up to the program to come up with the different designs and what it outputs using different manufacturing methods and materials. So let's take a look at some of the outcomes. This is a snapshot of one of the types of output that you can get for or from generative design, talking about price and performance. You know, we don't exactly generate the curve that you saw in the previous 2 slides, but you know, we can output a graph, something like you see here. So on the left-hand column, what we have here is the estimated manufacturing cost. And over here along the horizontal axis, we have the mass. And then in the different colors, what you see are the different manufacturing methods. So we have a 2-axis cutting in here, we have an additive, we have a die cast, we have a unrestricted here, and then some 3 and 5-axis methods. And so we have our plot here, and what we can see is that some of these have a pretty wide range on, you know, what it's going to cost, or hypothetical or estimated, I guess would be the right word to say that, estimated cost to manufacture. And excuse me, some of them are maybe lower cost, but you know, the mass is higher. So this is, again, one of the types of outputs, and it's up to you to investigate these different outcomes, and you can do that both in this graphical means and also with a visual means, and Apollo will show you that in just a little bit here. And again, determine, you know, where do we want to be? So maybe what you say is we want to be, you know, maybe somewhere below $800, right, to produce this part. So that rolls out probably a lot of these. And then, you know, you say maybe I don't want it to be quite so heavy, so then you end up somewhere down in this end of the spectrum. So some lower cost plus lower mass parts. Or if the mass is not a concern to you, or maybe you even want a higher mass part for something like, you know, some vibration concerns, you need it to be a little bit higher in mass, then maybe you are looking somewhere over here on the right-hand end of the spectrum, right? Or maybe cost in your particular case is not a factor for you, in which case you can explore some of these other ones. Again, we're not limiting you. We're trying to produce as many outcomes as we can, and then we leave it up to you as the end user to determine where you want to be in this spectrum. All right.
So yeah, with that, you know, I'll walk through a little bit on, you know, what the workflow looks like, go through a little demo, and then I'll actually, as Mike mentioned, open up Fusion and have that ready for any questions, as well as maybe show a couple websites, one that Mike referenced, as well as a couple others that you might be interested in looking at moving forward. But from a workflow standpoint, you know, Mike mentioned there were 3 buckets that we might approach generative design from, and this one is kind of looking at the, you know, part enhancement aspect of it. You know, we have an existing CAD model of some front suspension. You know, we're going to project certain geometries that are critical for our design, define those as regions that we want to keep or avoid, as well as, you know, some of our setup parameters, and then we're going to generate and explore, you know, the results. So if we go on to the next slide, we'll kind of step through that. As we set up those definitions, though, Mike mentioned we are manufacturing aware. So whether you're interested in seeing outputs that pertain to additive manufacturing or die casting or some form of milling, each of these can be toggled on and off. In a lot of situations, it doesn't cost any additional time to include an extra manufacturing method. So in many situations, I tend to tell people, feel free to include an additional manufacturing method just so that it can help give you a better understanding of how that part behaves and where mass is needed to fulfill some of your other requirements, because it might give you some other insights into your design. So, if we look at the suspension, we're kind of dealing with this front suspension, and is that having an issue, Mike?
Yeah, I see that. Sorry, let me.
It's all right. Do you want me to take sharing?
Yeah, maybe.
Okay, give me 1 second, folks. Sorry about that. There we go.
Thank you.
So essentially what we're doing is we're going to look at this A-arm and see how we might be able to enhance it, looking at other manufacturing methods and materials. So in Fusion, we're going to step into the generative design workspace. And then here we can actually make edits to the model that don't impact the original design. So we can use this as our test bed for different configurations. There's certain areas that we want to project, like those mounting holes where loads are going to be assigned, that we want to keep. And then we know that this suspension has to rotate about the frame and the chassis. There's going to be some mounting bolts that have to be passed through here. And so all of those are going to be obstacle regions that we don't want generative design to build geometry in. So we kind of just build those placeholders and then make our assignments. So those areas, again, that we want to keep, we're going to designate them as preserves, and they're going to be colored green. And then everything where we need to force an opening or a clearance for range of motion is all deemed as an obstacle region and colored red. From there, we can set up our design conditions. So, where are we going to fix the part? How are we going to assign the different load cases? So here we did a couple of them for, braking, acceleration, turning, the tire hanging. You can have a number of them as you see fit. And then get into the objectives. So as Mike mentioned, are we shooting to minimize mass, maximize stiffness? What's the safety factor that you want? And then what are those manufacturing methods that you're looking for? Is it additive? Is it milling? What size mill are you dealing with? What's the size of the bit itself, as that's going to dictate some of the complexity or level of detail we can actually get out of the part. Once we have all of that, we can assign our materials. As we get into assigning materials, and I can show this a little bit more, we do highlight which materials have a cost function to them, so which ones we will report appropriately what the associated cost is for a given manufacturing method. And then once we have all of our materials, we can do a pre-check to make sure everything is looking good, and generate our part. Once we're done with the generation, we can explore through looking at thumbnails. We can restrict on the left-hand side or filter based on a given manufacturing method, or if we have certain target ranges from a mass or displacement perspective. We can also view this as a table. Maybe that's a little bit easier to consume or sort some of the results by, because as we have so many outputs, it can be a little overwhelming at times. And then here's that graph aspect that Mike was mentioning, where we can look at them, we can change the legends if we need to, and I can highlight that, further, and say, okay, maybe this is one that we're interested in and we want to compare the two. So if we select both of them, we can compare them side by side. This was looking at two different manufacturing methods and different materials, and how are they different? Where is the mass concentration? What's the stress, distribution look like in the part? If we want, we can also showcase the original preserves and obstacle regions again, so that you can see how well we're honoring the original design space. And then ultimately, you make a decision as far as which one it is that you want to move forward with. And once we have that, we can actually promote that that specific outcome back into Fusion. So it becomes a fully modeled or full BREP that you can then modify, take into the CAM space if you wanted to start looking at, perhaps the time for doing any subtractive operations, things like that. So that is, a quick demo. I'll say the two things that I wanted to cover as well outside of that, Mike mentioned here the customer success stories around generative. I can put this link in the chat. And then the one that Anton also put into the chat already, which is around Autodesk University. So the fact that you guys are joining this today is a kind of great timing. It's kind of getting perhaps your feet wet as far as the topic of generative design. At AU this year, AU has gone completely virtual and completely free for the first time. So it's kind of a unique opportunity to take any and all classes that you feel may be of value to you. There are a bunch of classes given by a bunch of our customers, and there are a number of them around generative design. Many of them are being posted as on demand as well. So unlike we'll say physical AU, where sometimes classes are seat limited, you don't necessarily have that issue this year. So if interested in learning more, feel free to register and jump into any and all Autodesk related classes. But since we're talking around generative, anything that pertains there. And then lastly is kind of two comments. Is at the end of this webinar, if you guys want to talk more about generative with us, if you'd like us to reach out and perhaps talk more specifically about projects that you're getting into, there is a quick survey. It's 2 to 3 questions that says, yes, I'd like to have you reach out to me. Feel free to answer yes to that, and we'll reach out and see how we might be able to better help you. Second is, as far as learning, where do you go from here if you want to get your feet wet with it? Under our customer success learning hub, which is customersuccess.autodesk.com, under mechanical engineering, we have posted a generative design for manufacturing course. It's a fairly quick course. I think it, at most might take about 2 hours of time to go through the whole thing. But it does give you a great layout as far as the clicks and picks and some of the details behind the scenes as far as assumptions that are being made and how the tool works. So another resource for you to be able to move forward and take advantage of generative. So with that, I'll kind of open it up for questions. We still have a fair amount of time here, and so if you have any questions, feel free to put them into the questions panel, and we'll gladly step through them and either showcase it live or talk about it, whether it's conceptual or maybe where a certain button or feature is. The only other thing, I guess, too, that I'll comment, we are in kind of an alternating fashion. So for those of you that do go through, the connected learning content on the customer success website, we do try to hold an office hours periodically. So rather than doing this general overview of generative design, where we try to do a specific Q&A session for that. So definitely look forward to that if you do happen to jump into the content and want to discuss that content in more detail. Okay, so a couple questions starting to come in here. So what is the typical cost of running a model? Some of that can vary as to how you are accessing Fusion and Generative. Today, being that there are a couple different paths there, that cost can be different depending on the path, whether it's a, pay per, we'll say cloud credits per simulation submission, or whether you're kind of in a, all-inclusive pay for the month aspect.
They're coming in quick.
Yeah, which is good. Let's see. Is there an option for welded parts or formed parts? So that's a good question. It's one that comes up often. My comment there would be, if I come back to my page here, is if you take a look, and did we get rid of it? No, Claudius Peters. So what I'd say is it's very similar to how Claudius Peters approached using generative design. So as it stands today, welded parts or sheet metal is an area of interest for our product development team. What people are wanting out of it kind of varies, and so they are still trying to hone in on how best to suit that as a category. In the short term, it doesn't mean that you can't still take advantage of generative design. Claudius Peters is a great story around that. They deal with heavy equipment that is all sheet metal, more like plate steel, and it's all welded. And so they leveraged generative design, similar to what Mike mentioned, more on the ideation side, to see where is mass needed, where do they need to kind of concentrate geometry to focus on withstanding their load cases, and then building their part in their traditional format based off of the insights that they learned from generative design. So that would be the path that we would potentially recommend. Is it possible to do generative design on a product that needs to flex? I might ask for more information on that one. There are, as we look at the outputs, we do have details around the displacement. We can set even limits on, maybe a local displacement requirements. And so, if you needed to flex, you might be able to leverage that as a form of kind of allowing the part to flex up to a certain amount. But it may depend more on your specific definition of what needs to flex. I don't know, Mike, if you have any other comments.
The clarification came in that the examples of that could be a bow or a ski.
Yeah. Yeah, I mean, I guess, on just top of mind, I mean, it's that's a design constraint that you're allowing, up to a certain amount of displacement. And so so to that end, again, you might be able to leverage the local displacement to say, we want to allow a certain amount of displacement, for that given force, which would then allow that part to be flexible, based on that load case. Trying to think if there's any other way around that. So which tool did you, oh, go ahead, Mike. Yeah.
I think that, obviously the material selection would contribute to this, and the safety factor, right? The larger the safety factor that is applied to it, the more what do you want to say, beefy or rigid it's going to want to make the part to keep the stresses low. So you could go a little bit little less conservative on the safety factor as well.
Mm-hmm. Yeah, that's another valid point. I'll answer a couple of these pretty quickly. As mentioned, there's a cost function in here. Is there an inner program that knows the cost estimation? And yes, so we are partnered with A Priori. They're kind of a well-known company for cost estimation in the manufacturing space. They have a dedicated software on their end, that can tell you, where the cost for a given part comes from. We have a partnership with them, and so essentially that partnership is allowing us to access some of their knowledge and data. So based on the manufacturing method, based on the material, we can then provide this fully burdened cost, or part per cost approximation, giving you a given range or a given median value. So a lot of that information is coming through a priori and their algorithms. What tool did we use to define what geometry has to remain in the simulation? That's all part of Fusion, and that's all part of the generative design space. So, here you can see, the model that I have open. I've selected certain parts as part of the design space, saying I wanted to have some as obstacles. So those are like clearance regions for nuts, bolts, tool access, range of motion, or preserved geometries, which is where the force or load is going to be acting upon. And so if I hide some other geometry, you'll see the green parts are where I set up a number of different load cases. So whether it's just the tire hanging, acceleration, turning, twisting, things like that, you set up your load cases based off those preserved regions.
I think that follows right into the next question after that. What are the challenges in the software, and maybe you can add some of what you think your own. But I think at least when you're getting started, this is maybe the toughest one if you want to rank things. And it's just before you start the analysis, I think in my first couple of analyses, having to think through what needs to be preserved and what would be the obstacles. I think at least in the first couple analyses that I did, I'd go ahead and click the solve button or generate button, and then the outcomes start to get produced, and you can see them as they're going through the outcomes, or as the outcomes are evolving. And I would go, oh, there I can see, I needed to have another region that I should have made, an obstacle region. I didn't want it to actually build material there, or even forgetting to place preserves because I need something in the final solution so that it can be bolted or connected to some other structure. I think it's just a little bit of a different way of thinking for the setup of the model. versus you know, how those of us who are used to creating the entire design in a CAD package, it's a little different way of thinking, right? Because in something like Inventor, we know what that solution looks like, so we immediately dive into, you know, starting with a block or a cylinder and then either extracting or adding onto it. But here, you really have to think about, you know, what is around your object, you know, or you know, to a degree, what does the final shape look like in terms of those will be your preserve regions or something that you want in the final solution, but also what's around it that you need to avoid.
Yeah, no, I would agree with that. I mean, you know, that is probably the biggest challenge I see, you know, both for myself when I started it as well as others, you know, picking it up is, you know, what do I keep, you know, in this sense, if it's a part enhancement, and then, you know, if it's for ideation, you know, where are those connection points? You know, it is almost a different way of thinking about design because, you know, initially, you know, if you're looking at this part, someone might start off with just this entire hub here as what they're going to keep, you know, as their preserved region that they're going to assign a load to. When, you know, it might be possible just to say, I'm going to keep a smaller, thinner segment, you know, and if more material is needed, you know, let generative design add it back in. And so there is this, you know, balance of trying to figure out, you know, and that can also, I guess, you know, as well be a variation, right? You know, we have the ability to vary geometry, to kind of expand the number of outcomes that we get from generative design. And so, you know, perhaps instead of using a cylindrical, you know, preserve here, what if it was a square preserve, or what if it was, you know, 3 times thicker than what I initially drew here? You know, how does that change the final shape, or does it change the final shape? In some models, it has a huge impact because that connection piece is, you know, fairly load bearing, and in others, it may not. So it is that's probably one of the biggest challenges, is that you know, there are a lot of different opportunities for kind of exploring, and you know, how do you break it down efficiently for yourself? Which I think kind of goes into the next question as well, on talking a little bit more about techniques to minimize the amount of initial shape design work required. My ultimate goal is to use one of the generative designs at least as the foundation for the final design. And so, yeah, so as you deal with this with generative design, we didn't mention it, you know, too explicitly here, but you can define a starting shape or not. And so if you don't define a starting shape, essentially what we are doing is, you know, kind of combining you know, or wrapping around all of the starting shapes, or sorry, all of the preserves, and then subtracting out the obstacle regions and kind of evolving that shape to meet your load cases and design criteria. You know, in some instances, there can be an advantage to providing a starting shape, whether it's, you know, maybe the original A-arm, or in some cases, you know, we've done things like maybe a block with, you know, perforated holes blown throughout, so that it kind of gives the algorithm a number of different methods to, or surfaces that it can start moving rather than kind of playing with just the outer boundary. So, you know, each of those have, I'll say, a given level of effort, but then each of those has the ability to have a different impact on the final solution. So as far as, you know, maybe steps required to minimize the amount of effort, you know, I'd say generally the biggest issue that I see on the final effort comes around you know, how some of the generative shapes tie into those preserve regions. And so sometimes there are best practices as far as, you know, maybe filleting some of your obstacle regions or your preserve regions, so that the organic shape that comes in, if I look at, we'll just say one of these, the organic shape that comes into that preserve is a little bit smoother, kind of avoiding potential stress concentrations. Other instances, some people don't actually want even the last step, the lightest one per se. They might trickle back, a couple iterations and say, what, this one might be better suited, for what I'm looking for. So that question as a whole, I feel like it's there may be some process specific details that we'd want to get into around it, but generally the preserves and obstacles might be a starting point for minimizing future work. Mike, did you want to talk about the organic materials?
Yeah, sure. I was just starting to type up an answer, but I can talk about it. You can certainly, if there isn't a material in the library that accommodates what you are trying to utilize, you can certainly define your own material properties for a material that you utilize in the program. So I would start there, and there are a lot of materials available out there if you need to find what the properties are. It's going to use standard material properties that you might find. I come from more of a simulation background, so you'll need your Poisson's ratio and mass density, modulus of elasticity, things like that. So you can probably discover, and you can, all I'm saying ultimately is you can add the material in if you need to for a study. The downside, or one drawback here, you use the specific example of wood. At this point in time, the program is looking for isotropic material properties, where wood is generally more studied as an orthotropic type of material. That said, one trick that we would utilize in the simulation world would be that maybe when we enter in the properties, we take the weakest direction properties, and so that way we have a conservative design.
Okay. And just conscious on time here, let me kind of knock a few of the smaller ones out. What is the design output file type? So when you are done with your generative solution, if there is an outcome that you want to keep, you can promote that back into Fusion as an F3D. So you would have it as a full BREP that you could then export as any CAD type that Fusion supports, exporting, whether it's an IGES or SAT, things like that. Otherwise you can also export the outcome as a mesh file, like an STL, if you wanted to take that downstream into other, additive workflows that require, specifically an STL. Then there's another one here about, I just lost it. Are the results always organic or in shape, or is it possible to get more, call it linear aesthetics? So I brought this slide up just because some of that is dictated by the manufacturing method. So, some of the unrestricted types, and depending on how your preserves are, may be more organic shaped, more freeform. But as you get into things like 2.5 axis or 2-axis cutting, they will be, notably more, linear in their, aesthetics. So that's another way, if you will, to kind of see how that impacts the shape itself. Trying to make sure we don't miss any. Which 3D printing process will be good for manufacturing generative design parts? I think ultimately that's going to be dictated based on your specific part and needs and materials, since there are a number of different print processes out there, and each of them have their specific strengths. Nothing specific to our outputs. I would say it's more based on your desires and requirements than a function of how our part is built in Fusion. Anton, you've been answering some with links. Thank you for that. Oh, you taking that one, Mike, on fatigue?
Oh, sure. I was going to type it in, but we can answer it live real quick. The short answer is within the generative design environment, fatigue would not be considered right there. But if you export this to the simulation environment, within simulation environment, you can set up, different, it will import your constraints and your loads, certainly editable, and the material will be imported. So you can do analysis work there within Fusion simulation within its constraints of what it can do. And there's also a partnership with ANSYS, so you can export that out to the ANSYS program and perform subsequent analysis work there as well.
Yeah, and then would you add anything different around material properties under different temperature conditions to that answer?
I didn't see that part of it. Different material properties at different temperatures. Thermal analysis with a temperature dependent material property, still post generative design, more in the realm of the simulation environment. Doable.
Yeah,
just sim oriented more than generative design.
Okay, so you answered that one. Any option to choose powder, resin, or filament in the manufacturing tab? So as far as the manufacturing tab, so that gets into actually, the manufacturing environment and representing, additive there. As far as the generative output is concerned, we are just selecting, and if I go back to it here, when you pick your manufacturing details, you are just specifying information based on the additive process that you are going to be using. So, is there a requirement of an overhang angle that your machine can or cannot do if you want it to be self-supporting? What is your minimum thickness? And then, what is the orientation that you want to have it print? So by default, it'll look at this, based on the coordinate axis, printing in the, positive Z, positive X, positive Y directions. So if you wanted to have some off-angled orientation, you may want to rotate your part before running, generative design to see if it can, do that self-supporting aspect based off of one of those coordinate directions. But here we're not dictating whether it's a FDM, SLA, powder bed fusion. That's a downstream process, downstream step. There's a question on, is it Nastran under Inventor? I'm not sure where if there was more to that question, but here when you promote this, the outcome back to Fusion, you do get to leverage the tool within Fusion simulation, which will leverage all the setup parameters you've already done within the generative workspace. In theory, you could take that part to Inventor and use Inventor Nastran if you wanted, but you would not have the benefit of the load cases being transferred automatically in that sense. Yeah, the last question here is, we'll be given the option to run generative design locally versus using cloud credits. That's more of a product management decision. At this point, I have not heard of any discussions one way or the other. I will say, part of the benefit or reason, that it's on the cloud today is that we are, if you look at, my Explorer here, all of these runs are being done in parallel on, parallel machines. So the fact that if we were to do this locally, your machine only has a certain amount of capacity, which would mean that we would have to do things serially. And so where this full analysis took me, maybe 3.5 hours to get all of these outcomes, if I were to do this locally, if I had the capability to do it locally, it would be notably longer to do that locally, since it's restricted just to my resources. But that said, I don't know if there are any specific discussions to making a local version or not. Okay. I don't see any other specific questions coming in. I don't know, Mike, if you see any other ones that we've missed or not.
Amazing questions this time. So I handled
good.
quite a few through the chat. Great questions. So thank you guys.
Yeah, last one says, so ANSYS, is it for the simulation stuff? Yeah, I mean, ANSYS is a company that has a lot of simulation packages, focusing around FEA. So we do have a partnership with them, such that as you take this, as I was mentioning, or as Mike was mentioning, as you export this or promote it into a Fusion design, when you go into Fusion simulation, we have all the load cases, all the definitions already populated there if you want to leverage Fusion simulation. In some instances, people prefer to leverage ANSYS that they have access to. So we have a partnership with them that through a shortcut, you can export a deck and take that deck to ANSYS for running your FEA there. Okay.
All right.
I think that is all of them. I don't think we've missed any specifically. So, yeah, I appreciate everybody's time. And, as we mentioned, feel free to, sign up for AU. There are a bunch of classes going on around generative design. And, if you want to do your continued learning, feel free to take advantage of the Customer Success Learning Hub, for generative design or any of the other learning paths that we have there. So with that, Mike, you have anything else?
Nope, I think that's it.
Okay. Well, I appreciate everybody's time, and we will talk to you at one of the future office hours.
Thanks, everybody.
All right.